do it.
All right.
Okay.
Let's get you the microphone too.
Yeah. Okay, to cool everybody's fears, we're not going to put this up on NanoHub, but we're going to record it so that you get the feedback of being able to see yourself speak. And so it'll be kind of privately put up on YouTube where you can go watch it, but it won't be out for the public there. There you go.
Are you going to use the screen by any chance?
No.
I'd like to turn that off, because otherwise it's going to look like a Martian or Venusian. Blue. An alien.
All right, I'm Oluseyi Kamwede, and I'm working with Haimabadi and G over there. Say hi.
Hi.
And we are working on research with nanodiamonds, okay? Now, nanodiamonds are really cool. They're just like really small diamonds, all right? So essentially, if you have a diamond and it has a diameter that you're using nanometers to describe how like big or small that diameter is, you're working with nanodiamonds, okay? So our research primarily is concerned with depositing really thin films of nanodiamonds onto a substrate, in our case, just like a slab of silicon. We want to get like a really thin film with a uniform surface thickness onto this slab of silicon, okay? And this is easier said than done, all right? Especially if you're looking for a smooth surface like we are. The thing that makes this easier said than done is because, you know, there's a lot of challenges in doing that. First and foremost, obtaining nanodiamonds is actually very difficult to do. You know, I would just like tell a little short story, essentially. My very first purchase of nanodiamonds was from an Israeli company, and when we received the product, I was expecting, you know, like in the movies, like, you know, that crystal, you know, and shiny crystals and, you know, shiny crystal powder. It's not how it looks like, but that's what I was expecting. But instead, I got a jar full of soot in the mail, and I was just like, what is this? And it said on the label, nanodiamonds. Well, essentially, they had just taken the soot, taken a bunch of soot, put in a jar. But there was a reason for this, and that's because nanodiamonds are typically synthesized via detonation. That's how you get them. Essentially, you take a big hunk of carbon, you strap some TNT to it, and you blow it up, okay? So, you know, I have to give them credit because, you know, at least they gave us the results of the explosive process. So, the other major challenge is if you can find a manufacturer who will give you a pure sample of nanodiamonds, you typically run into what are known as aggregates. You see, most nanodiamonds are sold in like a solution form. Very few are sold in powder form. And in fact, you would want them dissolved in a solution, hopefully what's known as a stable solution. The opposite of a stable solution is a solution with aggregates, which tends to happen to nanodiamonds in water. It's just the facts. And like these aggregates are caused actually by the way that nanodiamonds are synthesized. 99% of them are synthesized via detonation. And this detonation causes, you know, there's a lot of heat, there's a lot of pressure that turns like this carbon into actual diamond that reinforces those bonds between the carbon atoms and turns them covalent. Well, this pressure and everything like that, you know, and the heat and everything like that, and also the fact that you're putting TNT, you know, on your carbon, introduces a lot of contaminants. And these contaminants, they bond to the carbon atoms that make up the, the matrix of your diamond. And these contaminants, they form what are called surface functional groups. And this entire process, which is known as surface functionalization, gives rise to aggregates in water. And the way that my team and I have kind of like risen, you know, to these challenges and worked to overcome them is we found a good, reputable supplier. And then to deal with the aggregate problem, we are using a method called salt-assisted ultrasonicated deaggregation, which sounds really complicated, but it's actually really simple. You take your nanodiamond solution, you add some salt to it, you sonicate it for a little while, which just means that you put it in what's known as a sonic bath, which is kind of like a jacuzzi for, you know, experiments. And sonicate it for a while, and then you do what's called a wash, where you centrifuge it for a while, and the nanodiamond precipitates out of the solution inside the centrifuge, and then you just take the clear supernatant, throw it away, and you have a completely deaggregated set of nanodiamonds. So I just wanted to talk to you about some of the challenges involved in thin film growth and what my team and I have been doing. And you know, the biggest takeaway is that working with diamonds is hard. Don't do it. Any questions?
What's your name again?
Shea.
Shea.
Yes.
I'm sorry. Did I introduce myself to your team?
No.
I'm the executive co-producer with Ali here, right? We hired the sharks to roast you in 2 weeks.
Excellent.
And Shea, the deal is this. And I'm going to be very blunt with you.
Mm-hmm.
I still do not see what story are you trying to tell to whom.
Okay.
So who are you telling this story to first?
Well, I was just telling the story about the difficulties of working with
No,
nanodiamonds.
who are you telling the story to?
You.
No. You are telling the story to the general public. So the sharks that will listen to you will try to assess if your story has legs, right?
Mm-hmm.
To sell it to NPR, right?
Okay.
Or to Popular Science, right?
Okay.
Or to whoever, right? So you need to have that audience in mind. So for that audience, there should be a reason to listen to your story, right? So the question is, what is it in your story that would interest that public, right? Let's think about it now. Let's think about your story. So your story is about what again?
Thin film growth.
Okay, thin film growth of
Nanodiamonds.
nanodiamonds, right?
Yes.
Now, I did not hear much about the reason why somebody would grow nanodiamonds on a film.
That's true.
So I'm not challenging you, I'm challenging the story. Now, don't get me wrong.
So I'm trying to do what's known as ion implantation. So I'm actually going to like take some ions and like use like a really strong magnetic field and shoot them at these diamonds that are on this thin film. But I didn't think that that was really relevant because that was also really a complicated idea.
Yeah, and that's not relevant for that audience that we're trying to reach.
Exactly.
Those people don't care about the ions. Your colleagues do care about that, and they'll go, share, you know, he's smart, you know, he really knows about ions and all that.
Yeah.
That audience there wants to know how your film will change the world. Will it change the world?
Yes.
In what way?
I'm making a single photon source. That's like the whole point of this. But I didn't really want to get into that because that's also really complicated.
Yeah, no. A single photon source of what? I mean,
Of light. So like a single
okay.
source of photons.
So when we get to that point where we'll have diamonds small enough, you use them
But
like
we
mini
are-
lenses?
So basically the general idea is you're trying to make a device that has an eternal state, and you need to read what that state is, right? But you need a state that can go into like a superposition, which is known as coherence. So you need what's called a single photon source, which will emit light of a certain polarization that you're going to read out.
Okay.
And you see, this is all very complicated, which is why I didn't want to get into
so
it.
what is the ultimate utility of creating that type of light source?
Because you're creating what's known as a qubit, a bit that can exist between 0 and 1, that can be in
This has
superposition.
applicability for quantum
It has,
computing?
yeah, some applicability. It could also be used for quantum information technology and things like that.
Yeah, but for people like me and other people who are not in the biz, the minute you say quantum computing, you know, my attention, you got my attention. I'm really
But that's
I'm
like,
really paying attention.
but my thing is like, I'm kind of upselling this to you right now.
Well, you're not. You are actually telling me why your work ultimately matters. Right?
Yeah.
You know what I mean? So if what you're doing can ultimately lead to creating quantum computers that do not need to be operated at almost 0 Kelvin, which
Yes.
is the case now, right? That's what you will do, right?
Yes.
Duh, yeah, that's really cool, right? Now we're talking. So, now, big story, long story short, actually sometimes these stories need to start with the very end, right? Which is where, you know, the rubber meets the ground, where what you do, you know, impacts the minds and the lives of people like me, you know, who don't know much about the soup, right? The ingredients that you put in the soup, but I surely could appreciate the soup at the very end, right? Now, I think that your project is super cool. Don't get me wrong, and I'm not disputing anything you've said or the quality of your thinking or even at the technical presentation. But you see, storytelling is about, you know, reaching out and touching someone, right? And you need to touch that someone on their own terms, right? So in my advice to you and your team is to kind of reel it in a little bit and start with the end, right? And actually talk a lot about these ultimate payoffs of what you do. And then once you tell people why this is so important, then you can talk a little bit about the obstacles you have overcome to reach this point, and why you deserve the attention of the world for having done all these wonderful things, such as, you know, you have to explode, you know, carbon atoms to make them diamonds. Could you believe that we make, you know, them by, you know, so you need to kind of, you know, advance in a way from the tail end to the front. Any other opinion? Thank you.
I do have one comment. You mentioned the word jacuzzi, and you use that comparison, you use that analogy as a way to get us to understand a certain part of what you were describing. And I would encourage you to continue to include metaphors and analogies and similes that would make some of the processes that you had to engage more accessible, so that, oh, okay, that's what it is. I know what a jacuzzi is, I might not know what that is. So I would say continue to do that as well when you're relaying that.
Thank you.
Yeah. All right.
Thank you.
Very good. Come on in. Now, I hope nobody was taken aback by this abrupt and brusque style, but believe me, this is how it's gonna be. This is a Shark Tank competition. You might have thought that this is a joke. It ain't no joke. We're taking it very seriously. Have you watched the Shark Tank? You have not?
It's more comfortable, you just drop it in your pocket.
Okay.
You can move around if you want to move away from the podium a little bit.
Okay. Thank you. Okay. Hello, everyone. My name is Sammy, and I'm representing here myself and my colleague, Carrie. We work with Professor Shakuri group. So I'm going to start with you talking about a little story that I lived while I was young. So I grew up in Jordan. It was like the 90s, beginning of the 90s, like late 80s. And I have a big family. I have 8 siblings. So 8 siblings, including my parents, were 11. And everything was a kind of a challenge. We had to compete. I had to compete not only with my twin brother, because I have a twin, identical one, and we competed in everything, in school, and it's nonstop competition until probably recently when I got married, like a couple of years ago. That's when we got separated. But anyway, I mean, even like, I remember my sisters, when they're like, if they're having a couple of friends coming over, they would like, and one of them is making like a cake or cookies, she would literally lock it in like a place where nobody can get to it. Because like there's a lot of hungry mouths we would eat anything. That's just the simplest thing. So anyway, we had a lot of like, my older brother was, he actually went for electrical engineering school. He's like 13 years older than me. And he, like my dad would spoil him and get him almost everything he wants. So he got him a nice Atari. I don't know if you remember the term. It's just like an old game console that probably is not very, very familiar these days. But anyway, we would like beg him to play on this stupid machine like once every weekend or whatever that is. And not only it was difficult to just get his permission to play, it was really like once we get his permission, we would we would probably spend like, he would play in front of us, and then we would cheer him up on that and say, hey, you did great. So we can just gain, you know, by tapping on his ego, maybe we can get a chance to play. But anyway, once we get a chance to play, we play a little bit, and then there's a stupid fuse inside of this Atari that would break up and burn out. And we had to, after it breaks, beg my dad again to drive probably an hour drive to the only place that supports this equipment and then get that fuse fixed. So it was nonstop failures. Now going beyond that example, think of things that might fail. Like if you're driving, imagine you're driving in a rainy night, it's snowing around you, and something as like the dashboard bulb would die out. It might not be something dramatic because it's just, I'm talking about probably right now just the radio and the heater bulb. So if it dies out, you probably will struggle in a highway, there's no light, struggle just to turn on your heater and put it to the right temperature. So you probably had to stop to the side of the road and figure it out and turn it on. Well, what if it's more dramatic? What if it's your speedometer will, let's say, lights turn off, so you can't see your speed. The simplest thing, you can get a ticket by going beyond the speed limit without knowing. But aside from that, you can really, failures could happen to your headlights and you can't see your highway. So jump ahead to more failures that could happen in any wire inside of your car. Your probably wipers would go down, a wire inside of your car will burn, and something, God forbid, like an accident would happen. Now we've gone a long way from incadenced bulbs to LEDs, for example, and the amount of hours that you can operate these LEDs is much longer, and they're much more reliable and cheaper to have on the long run. So what we do in our research, we basically have a high resolution microscopy, and we try to study the failure modes of electrical metals and wires in general, and hopefully to eventually understand it more and be able to improve it so we make it more reliable. One of the recent examples that we're working on is an aluminum electromigration project. We're basically studying how stressing your metallic wire, passing current through it, would eventually break your wire. Basically, there is a lot of heat generated around your wire, and we can basically, using this characterization technique, we can study the failure mode in high details and get a lot of data, thermal and electrical data, that would eventually help us make our devices, electrical devices, interconnects, and whatever you could imagine, this is more reliable. And that probably should be it. I'm not sure if I'd done just less than the 4 minutes or much less than that. But yeah, that's a quick. And I'll be open for questions or any constructive criticism. Constructive criticism, yeah, definitely.
You're looking like crazy man with a crazy eye.
Yeah, go ahead.
Okay. So what exactly is it that you're selling here?
I tried more like to actually introduce what we're doing rather than selling.
Okay.
So I would say it's
selling, metaphorically speaking, right? So you are selling in the sense that you are selling an idea.
Yes,
right?
I'm selling that.
Presenting an idea, right? So you heard me kind of, browbeating your colleague before, right? So if we are to kind of boil it down to the ultimate consequence and payoff, what would that be?
Improve reliability in our metal interconnects, in our light bulbs.
About light bulbs and fuses?
Yeah, something like that.
Fuses well, with the fuses it's tricky, because you want fuses to break, correct?
You're right.
You do want them to break.
You're right.
You don't want to make a fuse that is made of unobtainium, right?
Yeah,
It will
but
never break. If it doesn't break, your stuff fries. So in a way, your example, kind of went against you, right? Because if you are the guy who will make things that never break, the fuse wasn't the best. I love the story. The story was awesome, right? But your story should have been about creating something that is unbreakable, that you wish there was something that would never break, right? So you could have probably said, not about the fuse, but about something else that, broke all the time. You wish was made in such a way that would just, be new and cool all the time, right? And then transition to your story, which is about the quest of materials that last forever, right? And you need them to continue with that all the time, if that's what you guys are into. Are you guys into
I think so. I think, yeah, it's you probably, right now, when you summarize it, it came as in a nicer way, because I think with more training and like practicing on the presentation, you can focus on these points.
Yeah. So I want you all to think about it this way. None of the sharks will know a thing, cannot tell a boson from a proton, okay? They have no idea. I kind of do, but that's another story. I'm a weird guy, right? You know, but they cannot tell the difference. They don't care about that. Now, they do care about science and the impact of scientific findings on everyday lives. And they can tell a good scientific story by looking at its ultimate consequences. Again, think in reverse order, right? What is it that I'll create, and what is the best story that can go with it, right? Yeah. Cool. But, you know, you guys, again, you know, just like the other one, it's like, you know, who'd have thought that you can make diamonds so small that you can make 1 photon rays of light, right? Is that, you know what I heard she's doing? Yeah, that's really cool. All right.
Okay. Yeah.
Any other questions, stuff? I'm a little bit rushing this too, because not only I came late, but we only have time until 11, and everybody should get a chance to get you know, to get a little bit of feedback, so that they know what to expect next time. All right.
Thank you.
And by the way, for everybody, now kind of prep yourselves into your minds a little bit for the presentations. You know, compress as much as you can the technical aspect, because you are not here to tell the world that you did your homework, right? You're not talking to Ali, trying to convince him that he's paying you for the right reason, or whatever. You are talking to people who trust your technical expertise. They trust that you are not lying to them, right? When you say that you're going to do what you do. You don't have to convince them that you know, the technical part was taken care of, right? It's not like, it's not the peer review, right? You're not going to say, oh, but did you do the procedure in such and such way controlling for that? That's not something that you should wait on.
All right.
What's your name again?
Hi, everyone. I'm Akshay. I'm
Akshay?
Akshay, yep.
All right.
I'm representing Sina and Abhimanyu. We're part of Warsinger Water Labs.
All right.
Now,
how about this? Maybe the teams need to find a cool name, cool telling name.
Warsinger Water Labs.
Cool telling name. The unobtainium team, right? The laser, the 1 photon laser team. I don't know, I'm making it up, right? Is it what?
Batman Water Lab.
Oh, boring. Find something cool. Come on, go.
All right, so I want to talk today about water scarcity. So currently, we know that water scarcity occurs at having the usage of about 50 liters per person per day. Currently, the U.S. spends around 300 liters per person per day, and Cape Town, South Africa is actually under this number. It was projected at 2018 that the US would reach water scarcity. However, scientists have found a way to slow this rate down, but we're still approaching the water scarcity number. So right now we have this large untapped resource that is the oceans of salty, unpotable water. So the question is, how do we use this water how do we use the source to get fresh drinking water out of it? I guess the most simple and intuitive method that I'm sure everyone here is familiar with is just boil the water out. Why can't we do that? Well, that's really energy intensive. It doesn't really provide great results, and overall just very inefficient. So our lab is using thermochemistry, heat transfer, and membrane science to produce more water, cleaner water, all at a very low cost. So the way we're doing this, we use 3 primary methods: reverse osmosis, membrane distillation, and nanofiltration. Going through them, to simplify, reverse osmosis is basically we're taking water and pushing it through this fence and filtering out what we don't want and taking what we do want. Similarly, nanofiltration uses the same type of method, a very fine filter, to filter out what is important, and it leaves what isn't. Additionally, we have this technology called membrane distillation that vaporizes water through a membrane at a lower temperature. overall, the takeaway is that our lab can provide fresh water at a lower cost and reduce the water demand all over the world. Thank you.
All right. Okay. Now, these three methods, are they unheard of?
No, but they're underdeveloped.
All right. Which one is the least developed?
Probably membrane distillation.
All right. Very good. Good. Reverse osmosis. Everybody does that nowadays, right? I have like 3 of them at my house, right? Now, sure, you can improve it. You know, you can improve the efficiency of that, but that's not the point, right? Mm-hmm. So what was the one that you guys are really good at?
Membrane distillation.
Membrane distillation. How is that different from the other methods? Because there's still some sort of filtering process, is it?
Sure. Okay, so membrane distillation, what we're able to do is we have a temperature difference and a pressure difference, and we're able to vaporize water through a membrane instead of pushing it through.
Okay, now vaporizing instead of pushing leads to, requires less energy, right?
No.
No, it requires more energy?
More energy, but we're able to do it we're able to use the properties of water to vaporize itself rather than just purely adding energy to it.
But you see, me as the consumer, I want to know that what you're doing is really better, right? Now, when you told me that there's actually more energy, I mean, all my flags are like, these people are wasting people's money. What do you mean more energy? I mean, I don't want something that uses more energy. I want something that uses less energy. So is it more energy but higher efficiency? I can live with that.
Sure, we get higher efficiency, higher yield, so we get more water and we're able to get purer water.
Purer water. So when you do the cost benefits calculation, right? You get more water, I hope at a lower cost.
Yes.
You do? Yeah? You want to say something?
To get much higher purity water, it can be lower maintenance, you can do more remote applications, and you can use different energy sources, including sources that aren't currently being used.
Yeah, and overall, the trade-offs will come out, the trade-off will come out cheaper, right, than the trade-off for any of the other methods.
It depends. A big thing is it can treat water that you cannot treat with reverse osmosis. So you can do very high salinity waters that you can't handle with reverse osmosis.
Yeah.
So there's a bunch of applications that RO cannot cover, and membrane distillation can cover.
Okay. Well, we need to clarify all these things because, and clarify and also convince that your method is still a very good method for what you want to do, which is to get clean water out of unclean water, right? And that's all I care about as the naive listener, right? I want to know that you guys, because you started big. You said, man, there's a water scarcity on the planet. I want to solve that. And I want to solve it by, offering you this solution. And by the way, don't tell us about the 3 different ways. We don't care about the 3 different ways.
Sure.
We care about the best way, right? The way that will put this lab and Purdue on the map, right? That will make people go, these people really know what they're doing, right? And now, the fact that now this has a limited application by the end of the day, meaning that doesn't solve the world's, then you have to kind of reconcile one with the other, right? So maybe you should start your story a little bit different.
Okay.
Okay? All right?
Yep.
Good.
All right, thank you.
All right. Listen, this is like personal training. Have you done some personal training at the gym? With one of
I don't
those
want to
dudes
break this.
who are
I just.
frowny, not the lady who's like, oh, okay.
Thank you.
That's fine. We'll do another set. Oh, that's okay. You'll do it next time.
Yeah, I'll just hang it from when you're. Oh, okay, yeah. You're good.
This is like, I don't see the sweat. Where's the sweat?
So, hello everyone. Good morning. My name is Yashwant, and I'm representing my team with Joy and Muhammad, and we are from the same group as Akshay. So I won't be giving much introduction, but still starting with it. Like, what you need every day. Like your iPhone, internet, you need your clothes, everything. But what you really need every day, you need food, you need house, you need water. So like food is available right now because the government provides it securely. Air is available for free, at least till now. So the thing comes out is water. So water is also available if you see a large sea around us, 71% around. So, but can we drink that? No. We need to purify it to drink it. And what available is is like only 3% of the water all around the world is drinkable. So if this water is to be made available to everyone, you need large transportation, but we can't do that. So our goal is to provide safe drinking water to everyone at the place they are living. And like it can be at any remote place. It can be the Sahara Desert. It can be the desert in the Arizona. It can be near the sea where there is no fresh water. So that's our goal. And like talking about the desalination technology, that's the reason why desalination technology was developed. And I'm talking today about membrane distillation, which is a type of desalination technology. So this technology is already developed, but the problem which comes out is like it's very energy intensive, as my colleague already said. But we can think about making it efficient by using waste energy, the energy which is already let down by the factories. But still the factories can't be available everywhere. So what about a place where there's nothing? So that's when I realized we need to get a source which is available everywhere. And then I realized it's the sun. We can use the sun to get the energy for this desalination technology. So the story is like this. Like when I realized it when I was very young, my father is from a place which is in a desert and it's surrounded by a sea. So the water scarcity is going very high over there, and they don't have any kind of source for water, and what they are drinking is like arsenic, different kinds of elements mixed into that, and they're facing different problems. And the problem is like that's not the only place on earth which is facing that kind of problem. There are different countries and different places which are facing similar kind of problem. So there is no electricity there, there is no kind of energy source there, and that's what pushed me to take this project and think about it, how to make it easily available to everyone, how to make the solar thing match it with the membrane desalination technology and bring it together. Now talking about my project, or the topic which we are doing is, it's like we can use solar directly, like we can use PV cells, convert it into electricity and use that electricity into membrane distillation. But if we do that, we are decreasing its efficiency because we are converting the energy from one source to another. So what if I make it a direct system, a system which directly takes solar energy and directly purifies water? So this is what brought me to thinking about what if I make a membrane that not only lets vapor pass through it and purifies the water, but a membrane which absorbs the energy from the sun. So to make this, let me tell you what a membrane is. For example, a membrane in membrane desalination technology, distillation is which only lets vapor pass through it. It doesn't let water pass through it. Okay, and to make this membrane which can absorb heat from the sun, we thought of putting some nanoparticles into it. When these nanoparticles are attached or placed on this membrane, they absorb the heat and the radiation from the sun, and the membrane gets heated. Once the membrane gets heated, the water above it, just above it, also gets heated, and then it gets converted into vapor, and only the vapor passes through it. So this is the basic idea of this technology, and as I have already mentioned what was the purpose of this technology and what we are thinking of doing it, and the efficiency of this system may not be high, but it can be used in remote areas. It can be easily available to everyone, and it's compact. It's very compact. You don't need large solar panels, you don't need large tanks and all. You can just scale it down to any level you want, and you can use it. Thank you.
All right, very good. Very interesting. Now, is this the same project? You guys are working on the same project, the two teams?
Sharing projects, and we're separating some projects.
Well, when it comes to sharking, find a way to differentiate the two teams. Otherwise, they'll compete against each other. I don't know. We need to find a way to. Okay. Now, when we talk about I really like your story. The story is really cool. It's about making something out of nothing, right?
Yes.
It's very cool. Now, in order to sell it, and again, we're talking about selling the story in terms of convincing the audience that this is a really cool idea that they are buying into, metaphorically speaking, right? you need to kind of make them imagine themselves using it, right? So, if I were to go camping, if I were to use it, how can I use it, right? So, you need to add something to the story by which you tell that, this it might not be efficient, but it's very affordable, easy to make, cheap. Is that all true?
Yeah,
Is
yeah,
that all
yeah,
true?
yeah,
Right?
yeah, yeah.
Are these materials that are making this stuff readily available?
No, we have this technology is like a breakthrough we are going through, like we need to do it then.
Okay, so this membrane itself, what is it made of? What's the material?
It's like that can be made of different things, like you can make of graphene and different
graphene.
other stuffs.
Graphene, we're talking
Other stuffs, yeah,
right?
different stuffs you can make it.
Okay, so here you have to kind of explain that you're using very exotic materials. To me, again, graphene means something. To other people, doesn't mean much. But be very honest. Graphene is something really exotic, really hard to make, something that we cannot just produce like that, and it's very expensive under regular conditions, right? Yeah, is that?
Now it's not expensive.
It's not, okay, it's not as expensive as it used to be. But at scale, it might be expensive, right? And now, your biggest difficulty will be not only to convince them that these materials will be available, but is the ultimate argument about efficiency, right? Because you said yourself that's not very efficient, right? It means that you have a big installation to make a little bit of water, right?
No, we are making it down. That's the reason, like we are removing the PV cells and everything, and we are making it short.
Okay.
Like we are not using any solar panels. We are not using
but at this point with your prototype, how big, what's the efficiency exactly? What are we talking about? How big of a unit do you need to make a liter of water an hour?
Okay, it will be like scaling down it to 1/3 size from the normal.
How big is it right now?
It's still like you need this place, like it will be like 10 feet by 10 feet at least.
10 feet by 10 feet to produce 1 liter of...
No, like not that way. A minimum size of...
Actually, that's how you need to think about it.
Okay.
See, I don't care how you think about it. I know how the audience thinks about it, right?
Oh, yeah, sure.
The audience wants to know, so if it's this big, it'll produce this much in this much time, and it'll cost this much.
Oh, yeah.
Actually, the best way to convince the audience that what you're doing is really worth their time and energy is to say, a liter of water to pump from the ground, and ship it to Baluchistan
so give an example, you mean like?
Is $10 or $100.
Oh, yeah.
You might think that's $1, but actually the whole darn thing is this much. With what I do, I will boil it down to this. And that is actually the true measure of efficiency.
Yeah.
You know what I mean?
Yeah.
It's actually not the technical efficiency. It's the total cost of operation and production, right?
Sure.
Per unit compared to other things. And if now you can say right now we're at this because we're just a prototype.
Yeah.
But if we can reduce it by economies of scale by a factor of 10, and then we'll be competitive.
Yes, right.
All right.
Yeah, sure.
I don't know if your professor will let you disclose all these secrets. But if you want to sell the story to the public, you have to kind of get in the weeds on it. Okay.
Okay.
Thank you.
Thank you.
Now, this story was really good because it talked a lot about impact, right? And about the audience, about how people care about this and all that. So everybody think about it that way. Are we doing something?
Just pinch, yeah, there you go.
No, you can.
Perfect.
Thank you. Should I just go? Okay, good morning, everybody. My name is Jose Guaymin. I'm a first-year PhD student in material engineering, and that's my group over there, Sohan and Armin. And our team name is Flexible Sensors. We're not from the same lab group, but we're all working in flexible sensors. And the sensor that I'm going to speak to about today is a piezoelectric wearable flexible sensor. And that might sound really complex to some of you, but the first story I'm going to tell you guys is I want you to picture this. It's a beautiful Saturday afternoon. Purdue is playing Ohio State. It's the fourth quarter. We are winning by 7 points, and we're on the 30-yard line, and it's our fourth down. And it's only 7 points, so we know it's 2 minutes left in the game. Ohio State can still come back, so we say, let's go for it. So our quarterback sets up the play. They give him the ball, and boom, he just got hit. He's on the floor, unconscious for like a solid minute. He gets up, he's okay. But then we see the doctor tell something to the coach. The ref comes out, and they take him in an ambulance. Now, he seemed okay. He was up. He was walking fine. But he went to the hospital. Later, we find out in the news that he had a concussion. Now, how was the doctor able to tell that when the player was
looked fine in the field. That's where a pressure sensor made out of piezoelectric material would be ideal in this situation. So the sensors that are being produced in the lab are made from, as I said, piezoelectric material. What is piezoelectricity? Piezoelectric material is material that, when, upon a pressure, they will release a voltage. And as most of you guys might know, you can measure voltages very easily. Another thing that you can do very easily is connect this sensor to a wireless device. So a device that will transmit this voltage, this reading, wirelessly to the doctor. So with these wearable sensors that we're making, we can create a sheet that can cover the inside of the helmet and ideally measure the pressure and turn that into the force that is being applied on his skull. So we can get an immediate reading of how much force was applied into his skull and say, this player might have a concussion, and safely remove him from the field. Now a second story, which might be more appealing to the non-football fans here, is with babies. There's this very common but not too known condition for prematurely born babies. So prematurely born babies, around 7 months, they usually have this thing called sudden infant mortality, which is a situation where the baby is so weak because it's prematurely born that the pressure caused by his own body when they turn around in their chest doesn't allow it to breathe, so they suffocate. Now the idea is that by using this material, you can create a sheet, a flexible sheet that will allow the baby to sleep. It's not full of cables or anything that can harm the baby, but you can measure the pressure on the baby and hopefully in the future map out how the baby's sleeping. So you can get a signal when the baby rolls onto his chest, so the parents can go into the room and just lift the baby and make him go back to his back. So instead of being a father, being worried, not sleeping all night, just looking at your baby, or having to send him to a hospital for months so that he can be constantly monitored, you can have a sheet that can allow you to monitor your baby and have a good night's sleep. That's
all right, very good. Jose, my dear, in Soviet Russia, baby sleeps, daddy sleeps. Nobody cares about baby. So you tell me, how is this really different, right? Again, both situations. Let me go back to this thing. We all play actually with these lit up balls, right? The rubber balls that light up when you hit them on a wall, correct? Kids with those unnerving sneakers that light, when they step on them. You know what I mean? You know what I mean? The LED sneakers, right? Those are piezoelectric sneakers, right?
I'm not sure.
Oh, they are.
Yeah, sure.
Of course they
I
are.
believe.
And those balls that light, the rubber balls, those
Yeah.
are piezoelectric. And there's a piezoelectric material in it that, basically generates a little bit of electricity that lights up those LEDs inside, right? That don't need much electricity, right? So the piezoelectric effect has been around for 100 years and a day, right? It's not something new.
Yeah, no.
No, okay. Right, now, pressure sensors that use piezoelectric effects are not something new, right? You guys did not come up with them, right? So, what is it different that you guys are doing, right?
So it's the idea that you can create a flexible, wearable piezoelectric material.
Okay, so a typical piezoelectric
Tile.
device is rigid,
Yes.
right? Yeah, and it involves what, metal or something? Yeah?
Yes, has to be on a conductive sheet.
This material is also transparent.
Okay.
It can be used for some transparent applications.
Oh, okay, transparent. But before we get to transparent, we're talking about flexible, right?
Yep.
Moldable, flexible, right?
Yep.
Light, right? So your advance is in making these things behave in a different way, right? It's the equivalent of the polymer lithium battery, right? Which are moldable, right? Our old batteries, they're all bulky and round, and they have to have a lot of metal in them. And now these batteries that we have in our devices, that you can shape them in whichever way you want. I mean, the idea is that you take a technology that's very well known, and then you find a material that does the same trick, but in a different context with a different utility, right? So that's where your selling point is, right? So, and actually, whenever you are talking about the technology that's known, right, that's been used for some time, be modest and open about the fact that, listen, we're not working on this. This has been done for 1 million years. What we're working on is this other thing that was not very easy to do, right, for all these other reasons. Now, are these membranes or these, things that you're coming up with more energy efficient?
They're ultra sensitive, first of all.
Oh, they are ultra sensitive,
They're much more sensitive.
Well, how much more sensitive?
We have a good demo to show.
All right, good. Well, not just a demo, find the word, right? It's the equivalent
It
of.
can sense the bird feather touch.
Okay, very good, right? And you can say, but find an example. It's like, previous devices, it took the equivalent of a sledgehammer to get the signal. Here you can use a feather and you get the, you know what I mean? Maybe it's not a sledgehammer.
Actually, we have a good comparison.
All right.
The amount of voltage that we get from a tiny water drop, people get from a bigger touch.
All right, very good. Right, so that's where you need to put your money. You need to bet on the novelty of the sensitivity, flexibility, taking this place where it's never been and that kind of stuff. All right? Very good, thank you. I don't know, how many more teams do we have?
Should be 2 more.
2 more? Okay, young ladies, let's go. It's time, that's it.
Sorry, I have to be able to go first.
Oh yeah, sure, you no,
Time runs out.
they have a class or something? No, that's Sandra, right?
Yes.
Okay, one other thing. Especially if your name is not
You pinch your shirt together a little bit.
Soren, okay?
Like this.
It's not a name that
That's
everybody,
the clip on this
has
side
on
though,
the tip
because
of
of
their
where the
tongue.
clip goes.
Very important, when you introduce yourself,
Yeah.
say your name, say it loud, say it clear, say it slow, wait. Why? You want people to see you as an individual who has a name, who is there, who's somebody, right? You don't mumble your name, ever. Especially if your name is not a non-English name, right? That's the worst you can do. Actually, that makes you look defensive and weak, okay? You say your name loud, clear. You can even crack a joke about it. If your name means something like Rajesh, which has to do with kings and kingly people, make that. My name is Soren, comes from sun, it's sunny. You know what I mean? Make a statement about you being there. You want people to notice that you're there, right? You're not the voice of somebody. You are you, okay? Then, after you leave a pause for people to think, don't say who do you speak for, right? And that's why I said you have to have a team behind you. Say, we are the team X, and we are doing this. Mark your territory, right? Just like a cat marks the territory by rubbing her head against her masters. That's why cats do that? You thought that was love? That's not love. The cat tells other cats, that's mine, okay? Don't touch, all right? You do the same, right? You say, I'm team X, and we do Y. Actually, even from the very beginning, the team name and all that, try to mark the territory. We're the membrane, of doom team, or whatever. The piezo, you've never heard anything like it before team, all right? Okay, good. Now, I mentioned this while we had Sandra walking, because when she introduced herself, Sandra was very clear and direct. I said, what's your name? It's Sarah. Sorry, Sandra. And then I said, is it, whatever. No, Sarah. Sandra. I said, okay, Sandra, good. All right, go.
Okay, good morning, everybody. My name is Sandra. I work in the same team as Abimanyu, and we are working in a water team. So the name of our team is Neptuno's team, because he is the god of the sea. So we like it. So I would like you to try to think in a beautiful, sunny summer day, and let's say you're playing outside and you are very thirsty and you want to get some water. What do you have to do here in the United States? What do you have to do?
I just go inside and get water from the
Okay, it's easy, right? But maybe not for everybody is that easy. Maybe not everybody has this possibility of just go and open the tap and get water to drink. So let's say in my country, I come from Colombia, and in my city, one of the ways that people have to get drinkable water is just go to the rivers and just take the water directly from the river, because we don't have, well, not in all the cities, but in most of them, we don't have a water treatment system. So what we have to do is go to the river and drink directly from them. But the water in the rivers is very contaminated, let's say with mercury from the mines, let's say with the soap, because people used to wash the clothes in the river. So you have to deal with all contaminants and use this water to drink. We have a very multicultural group in our team. So let's say in India, we have an example where you don't have enough drinking, like fresh and drinkable water, so what you have to do is try to mix up the fresh water with some non-potable water, and this is the water that you use in your house for your children. So now I want you to try to think that maybe 97% of our planet is covered with water, but only 3% of this water is drinkable water. So it sounds like a good idea. Try to use this seawater in order to provide people with fresh water to drink, right? So, but how? How can you do that? The thing is that we have now available a lot of different ways to desalinate this water, but maybe the best idea and the best process that we have now in order to desalinate the water is the reverse osmosis. The reverse osmosis, I'm not going to get into details, but basically you have to push water through a membrane, and in that way you can separate the water from the salt. This is a very energy-intense process, and you consume a lot of energy and electricity by doing so. So the thing is, how can you improve this process? What do you have to do in order to improve this process? We have something called a specific energy consumption, and this is basically how much energy do you have to use in order to produce 1 cubic meter of water. With a traditional system of reverse osmosis, basically you can have a specific energy consumption of 3. This means that you need to use 3 kilowatts per hour of energy in order to produce 1 cubic meter of potable and drinkable water. What we are proposing now is one new system, a brand new system that is called BIRCK, that is called batch reverse osmosis, in which you have the possibility of reduce this specific energy consumption from the same, I mean, if you're working with the same characteristics of your feed water from 3 to 0.5, or it depends of the water you have, but maybe from 3 to 0.5 or 0.7. How can you do that? When you are working with a traditional reverse osmosis process, what you have to do is try to pressurize the water to the level of the pressure of the brine that you have at the end. But what we want to do is try to follow the curve of the osmotic pressure of the brine. So the osmotic pressure of your feed is going to increase over your process. So you want to follow this curve in order to save all this energy that you are not able to save if you work with a continuous reverse osmosis process. So we want to work with desalination technologies, but our focus in our team is how can you do it in a more efficient and in a more cost-effective way. Thank you.
Good. Yeah, now for once, and I can't say anything about the science part of it because I'm kind of lost. And that might be a problem, right? So the follow what? You were mentioning that it has to follow what toward the end.
Okay.
Something has to follow what?
Okay, so with a traditional process of reverse osmosis, what you have to do is you have to put some pressure in the water in order to make it flow through the membrane.
Okay, so it's like you have to push it through.
Yeah, exactly.
You have to force it through, right?
Exactly. So you have to work with a fixed level of pressure. And you know that the energy that a pump is consuming is proportional to the pressure that you have. But with this new process, what you do is you pressurize the water in a low level first, and you increase the pressure in the way that the osmotic pressure increases. So in that way, you can reduce the electricity that is being consumed.
You lower the cost of pressuring by applying the pressure in a different way, in a more kind of calculated way.
Basically.
Yeah. Good. And for that, you have like some sort of computer algorithm? You have a computer controller that does that?
Not a computer. Actually, the system itself controls the pressure.
But in order to make the system itself control the pressure in that way, did you have to, how did you do it? I mean, is it an electromechanical device that you invented?
It's an hydraulic device.
It's an hydraulic device, and there's the controller, a smart controller built into it, or
well,
is it self-regulated?
With the system we are proposing, you don't need an electronic system to control it.
You don't need an electronic.
No, you control the pressure and the volume in the system with the with the potable water that you are producing.
Okay.
Because you have a tank, and in one side of the tank you have the brine, and in the other side you have the drinkable water that you are producing.
Okay.
So this water is going through the tank and is pushing the brine. So in that way,
this is a pure engineering solution, like a smart engineering solution for, you know, kind of doing something different. We're using about the same methods, but in a very different way.
yeah.
Wonderful. And what's okay, good. So that's how it needs to be explained, right? So we are doing
Okay.
about the same thing everybody does. Well, we only found a better way. We invented a smarter mousetrap. This everybody gets, right? You know, instead of catching the mouse that way, we catch it this way. Now, by how much do you expect the cost to drop because of your method?
Okay,
So you said from 3 to 0.5?
yes, basically, if you have a continuous reverse osmosis process, the specific energy consumption is around 3.0. That means you need 3 kilowatts per hour to produce one cubic meter of water. And with this new method, you can use maybe 0.5.
Okay, so always talk not 3 to 0.5, always talk times, right? 3 to 0.5 is how many times?
Okay, maybe almost 3 times.
3 to 0.5?
No,
Three times?
2.5.
6 times.
Okay, yeah.
It's like 6 times, right? It's like 6 times better, right? It's an increase of 600%.
But that depends on the recovery ratio that you're using. But if you have a recovery ratio of 50%, yes.
Well, in any event, it's, again, advice for everybody, never use absolute numbers. They don't mean anything for anybody. People don't do math. They don't know math. They cannot do ratios. They're not good at that. Tell them times, and emphasize, say, this more many times is not just an increase of 1% or 10% or 100%. It's 600%. It's 6 times better. Now, if this will work at the very end, will the price drop dramatically?
Yes.
As your energy consumption drops, but will that make this type of water, production competitive with water from? You need to drop that in. I'm not asking you to give me the number now, but you need to, because again, you are trying to convince people like me, right? Who have an interest in this because we care about the planet, not because we care about your pump.
Okay.
Right? All right. Thank you. All right. Last but not least.
That's not my phone, it's just the timer, just so you have.
Yeah. You see how good we are? She gave the speech and the feedback and the second one.
Oh.
Yeah, we're all speaking.
Oh, okay. Just if you all close together like this, it would be just fine. We'll put it on the center. You can just clip it on your lapel thing right here. It'll be great shape. Yeah, and that should pick up everybody.
So remember, name, clear, maybe a joke, pause, right? Name, clear, maybe a joke, pause, right? Don't rush it.
So hello, my name is Lucia. I work with Professor Rahimi, same as them, but we're not involved in the same project. So we're not going to talk about our actual projects, like what we're doing right now. We're talking about a project that Alexandra has done previously. So she was telling us about the project. I remember one story that a teacher from my school told us. So my school, by the time I was in school, I was building a school in Africa, in Benin, in a small village called Kalale. So she was telling us like how life went, and one of the things she told us was how all the kids took like 2 hours to get to school, or maybe 1 hour, or even less, but a really long time to get to school. And like really dramatic story that she told me was a mother had this child that was very ill, and the baby needed to go to the hospital. So what she did, she took the baby, and he had to go by car to the hospital. So she went with someone else, and while they were driving to the hospital, it was maybe like 100-kilometer way till the hospital from the school, but it took them 3 hours. So the baby died in the way. So it was like she told us this story, like that it really impacted her, and so like how roads are built, and how many the interconnections between the roads and everything. It's very important for our everyday lives, but it's also can be like life-changing for someone else, for a lot of people. So what if I told you we could change this? We can make roads in a cheaper way, and we could even harvest materials that are waste and are contaminating. So that's what Alexandra was going to tell you.
Well, this is a thing that just cannot happen in some countries of Africa. I was born in Colombia, and there are many very apart cities, like knowing the main cities, but there are many cities that are like in apart size, and they take a lot of time to go to school or to go to a hospital. So in my project, the project that I was working on, we were trying to make affordable roads for normal people, for these small cities or a small village. We were trying to improve the asphalt roads with wastes from industrial making, from steel making process, or from coconut fibers, like putting into the asphalt in different proportions to measure which one is the best, or which kind of waste is the best for those roads. So yeah, we were trying different wastes, and also the proportion of those. And the advantage of those wastes introduced into the asphalt were very productive, and we get very good results.
Well, she did introduce me, but I'm Beatriz. I'm from Spain, but just to make it easier, we can just leave it in Beatriz, which is what I normally do. So now when we look into the future of this, we can obviously see the part where it has an impact on the actual contamination of the, and how you manage the residues from the industries and everything. So we could actually be able to reuse this residues that are being created and implement it into into a new manufacturing process of this asphalt. But apart from that, not only is the contamination part, but as we're always looking at, what would the company benefit from? Why would the company benefit from it? So one of the things is, normally the residues that a company produces or an industry produces, they're being regulated. So we could actually be able to as we're using the residues, they'll be producing less residues. So they'll probably have, you normally pay for what, from what I'm aware, it's just as we just decided this like a few minutes ago, I'm not really sure, but you would be able to reduce the amount of money that they're paying in order, as they're reducing the residues that they're producing. They would also have like the human or the humanity part, where they're actually helping other countries, and they're involved in developing them. And also you can counterbalance this and use not only reduce the residues, but use the money that you're not investing like to pay for the residues that you're producing, but also to develop and take that money into the research of developing these new technologies. So yeah.
All right. Now, this is a past project. This is not the current project.
Yeah, it's a past project.
It's a past project, and you'll still want to sell this project next time, right?
Yeah.
Okay, good. That's fine. It doesn't have. You don't have to. Then you don't try too hard to explain why this project, why not this project, why it's not related to the Nanotechnology Center. Just don't get into those details. That's a distraction. You know what I mean? Just say this is our project. All right, good. Now, what's asphalt?
Asphalt is the material that you use to bind the aggregates in.
No, listen, I, as an ordinary individual, I know what asphalt is. but you need to re-explain now to me and to everybody else what goes into asphalt. What is asphalt, right? Asphalt is a road cover material that has the following properties, right? It binds at a certain temperature and then it stays bound. Then it's porous and it doesn't crack as easy. You know what I mean? Or what makes asphalt asphalt? Why is asphalt an appropriate building material for road covers, right?
Yeah.
Right, and then you need to talk a little bit about the difficulties of getting good quality asphalt, right? Asphalt, you know, compound. It's not just the asphalt itself, which is just the binding element. It's the additives and all that, right? That's not cheap, right? Now, and if you don't happen to be a Middle Eastern country, right? You don't have a lot of that, right? Because you know again, what's asphalt exactly? What makes the asphalt asphalt? What's the binding compound in it? The derivative of what?
It is a compound of 3 different stuff. It's asphaltenes and maltens.
And where do they come from?
It is as a byproduct of the oil
industry, right? So you know, if you have a lot of oil, you have a lot of asphalt. If you don't have a lot of oil, you don't, right?
Yeah.
If you're in Africa and you know that the closest oil field is whatever distance, what do you have to do? You know, buy it and bring it. And it's a bulky product, it's an expensive product. It doesn't, you know, there's all kinds of things, right? So having a way to create asphalt on the spot using substitutes for some of the elements that you can recover, it's a double whammy, right? You don't have to pay the producer, and then you can recover the things that you have on the spot. Now, this is a very common story. Everybody, you know, goes for it. But everybody goes for it when you can show that what you do is not only a substitute, but is a better substitute, right? You know, I grew up in Romania during the 80s. Romania during the 80s was not a very pretty place. It was like North Korea, right? You know, the communist regime was collapsing upon itself and was not capable to feed its own people. Bottom line, that's what socialism does to you, by the way. And one thing, the first things that disappeared from the shelves of the stores were the luxuries, such as coffee, right? Coffee was impossible to find. Why? Romania is no, you know, it's no Ethiopia, right? It's no Costa Rica, right? We don't grow, you know, coffee there. So what did people do? Well, you know, they started using substitute coffee, right? Are you aware of the substitute coffee that you can actually buy from the store? It's called Cava. No, Nescafe is the real thing. No, that's the real good stuff. Gee, you know, these people were really spoiled wherever she grew up. It's like when you don't get coffee, you get the instant coffee. It's like, no way, girl, that was like the bomb. You know, you got Nescafe, that was the awesome thing. So people started using, you know, substitute coffee, which was basically was roasted oats. Roasted oats, which tasted a little bit, the burnt taste tasted like coffee. There was no caffeine in it, no nothing. There was nothing like coffee, but it sounded and smelled a little bit like coffee, and they said it's good enough for you to be coffee. So the Romanian called it hehol, like, no, nehol, like a neigh, you know, like what the horses say, you know, like nehol, which is like the neigh coffee, right? Now, a substitute coffee, right, that, you know, was offered to the people was a terrible coffee, which people hated, okay? One reason why that regime collapsed is that people just could not put up with that coffee, right? Bottom line, if you propose a substitute for anything, that better be good. You know what I mean? So your argument should not only be that it would be a great idea if we used, you know, coconut, you know, scrapings, right, shavings, to put in the road, right? You have to show it's like, man, this is not going to make your road smell like coconut pie and melt just as easy, right? They're going to be better, right? They're going to be more durable, more whatever. And you can give an example. This is the equivalent, you know, making your park benches from recovered plastic rather than from wood. Wood rusts, rots, dies. You know, those benches last forever. Sure, they don't look pretty. They don't look very good, but yeah, you have to, you know, whatever. See what I mean? So your argument should be about, you know, the better aspects of it always, right? And the recovery of waste materials cannot be the most important thing, again, because especially the recovery, the thing involves things that are not supposed to be stored. You know, what kind of argument is that? Are we now, instead of storing the toxic stuff in the heaps, in the garbage heaps, we put them in the road? Well, that could be even worse than, you know, hiding them in the ground, you know what I mean?
Yeah.
So, you know, don't talk about them as if it's the bad stuff that we take from there and put it there.
Yeah.
Actually, that can fly right in your face, right? Okay, has anybody done this?
Yeah.
Is this something that's done?
Yeah.
How many kilometers of roads were built with this material?
Well, I left the project, but it's still.
Well, do some research, see how far they got.
But no, but it's still in testing.
Yeah, well, but still, you know, look at the numbers.
In parks and so on.
Well, you know, look at it and see how happy they are. Look at the price too. You know, again, it could be better. It might be better. You know, it might be better. You know, I'm not saying it's not better, but make sure that it's not better and more expensive too. Because again, there's the fact that something is a waste material doesn't make something necessarily cheaper, right? Because the waste material doesn't come in a pure form. There's no such thing as pure waste. Waste is waste because it's waste, right? So you have, just cleaning the waste is very expensive. And by the end of the day, you might realize that you better, you know, use something new. That's why not a lot of recycling doesn't go as far as people like to think they should go. Because, you know, once you use paper once, you can only make toilet paper out of, you know, recycled toilet paper that many times. You know what I mean?
Yeah.
That's not even a good idea.
That in some sense, you are telling a story, and part of the research is what you learn. It's not that at the end everything should work. You can say, we wanted to do this, this is the main reason, this part worked, but this part didn't, and this is the lesson. You know, this is, you can tell the story as what was the research, the whole idea.
Now, you can present as a trio, that's perfectly okay. However, you know, very honestly, you know, we have a distributed team here, which, you know, has different talents in different ways. The more assertive speaker is she, right? You know, she's just naturally more assertive, right? And you know, and you are the more thoughtful, you know, the data and numbers and all that better, the way it appears. And you know, you can crack a job, you know what I mean? Either try to have one speaker and the rest, you know, divides the work on the side, or if you all decide to speak, decide to take the speaking parts that fit your talents and your, you know, your psychology, right? It's like an opera, right? You know, there's the tenor and there's the soprano, right? And then there's the whatever, the bass, right? You know, for each part there should be the appropriate person. Not everybody should do the same thing. And again, you know, you did not follow my advice. You know, she said her name clearly and stopped, right? But then, you know, you kind of forgot about it. You know? You didn't let her introduce you. By the way, introduce yourselves all at the very beginning. Yeah, as if you were a trio, you know, giving a performance. You know what I mean? All right, thank you.
What should be the objective of the presenters here? The Shark Tank competition, as I understand, is very much from a commercial standpoint.
Yeah, no, here is
private. You know,
no. You don't sell stuff to them to give a share in your business. Material. These sharks are media professionals who could take an interest in your story to help you spin the story further.
So we're trying to persuade that this is a good idea from a societal standpoint.
And a good story that could be told to the media and then further to society. Yes. Yeah. This is a storytelling Shark Tank competition, right? You're not trying to convince. Now, sure, you need. You know, I talked about efficiency, money, and all that, but that's not the point. You know, you're not trying to tell them that you'll make a good investment. They have no money. They'll give you no money, right? They're poor employees of this fine university, all of them, every single one, right? But they have knowledge that you seek, right? You work with Abra will spin your story from corn silk into pure silk, if you know what I mean. You can make a nice scarf out of it too.
I guess the same question in a different way. Would people with a final product, like currently having a product, for example, like the wearable flexible sensors, have an upper edge compared to people who are trying to sell a general idea or a method that might have potential in solving?
Remember, you're going to need to use a visual aid, right? So if you have a prototype that you have a generated image of, rather than the physical item, you can still be, you want us to be able to see what it is that you're talking about. So how can you enhance our understanding of it? If you don't have an actual physical prototype, then you could generate one, like an image of one.
I think what Sammy means is, since a research university here, a lot of us are working on projects that are funded by the government specifically because they may not have an immediate commercial application. If it was going to make sense from a business standpoint, the private sector would be
Well.
So we may be, for example, we're working on something that's going to improve reliability of electronics in general. That may not have an immediate, application, may not have a product or a physical, tangible result, but it's an understanding, it's an advancement of our understanding.
Yeah, I understand, but you see, when Ali and I got together and talked about this, our idea was to up everybody's storytelling game. That's our game. That's our goal here, right? It's not to, how should I put it, not to help you get grants. Okay? We'll have that too. We'll do that too. Promise. We'll do a session where we'll teach you how to think grants and all that. But this is about storytelling. Now, storytelling can only be trained if you put yourself in that situation where you're trying to sell whatever you have to sell to a broader public, right? Than your immediate colleagues and reviewers, big newspaper. And that's the goal here. And this prepares you for that situation when your stuff, which is funded by the government for obscure reasons, might, just, pop, as they say, right? And you'll get that 1 in a million chance to shine out there in front of the great masses, Wall Street and all that, right? That's what we're preparing you for. Hope that day will come. I don't know, maybe it will not, but I hope it will, right? Yeah, let me put it this other third way. But this is a game, all right? The Shark Tank, we went, all this, distance with the sharks and all that to, highlight that this is a game, all right? It's a training by having fun and by stretching our imaginations, by trying to come out of our shells, right? By doing it different, right? By putting ourselves in the role of, right? And we went for this formula because it forces you to perform, right? Perform, not in terms of do well, but perform as in perform in front of an audience with expectations that are not always your own expectations, right? And that's what a good communicator really does, is really good at. A good communicator is really good at performing, at delivering a story of her own to an audience that's different than what he or she is used to. Now I had a little spiel for you, and you'll get an article from us to take a look at, which speaks about interesting research. Please do take that piece to heart. It's a wonderful piece. It's a little tongue-in-cheek. You might at times you might shake your head and wonder if he's really serious. But this piece says one very simple thing, which should be part of your presentations. No good story, no good research is good until it's interesting. See, no good research is really good until it's interesting. There could be a lot of good research that is good, but it's not interesting, that's not really good. So all good research is interesting. How is it interesting? It is interesting by violating assumptions, by violating your public's assumptions. Right? What does that mean? Well, you need to tell the public something the public does not know. No. You need to tell the public something that the public knew it was otherwise. And now you're telling them that it is actually this other way that you just came up with, which is the better way to think about it. And that will make people go, wow, that is really interesting. So, in order for you to be a good storyteller, first of all, you need to understand what the public knows about your stuff. Right? What the assumptions about your thing, the thing you're trying to tell them are. And then you need to try to explain to the public how what you have to sell them will change the way they think about that thing, about that process, right? Everybody here spoke about things that we kind of know about, water desalination. No matter how uneducated a person is, they kind of know that you can't get water out of, you can drink, the seawater if you, at the very least, do what they taught you in Boy Scouts, right? To take a sheet of plastic, put a rock in the middle, put a bowl of water under it, right, and the water, and a big bowl of salt water underneath, and then another smaller empty cup in the middle, right? You know what happens? Water you know, vaporizes, it condenses on the sheet, and then it drips in the middle, and that's, yeah. Everybody has some sort of naive idea about it. Everybody uses reverse osmosis. Everybody has heard the word reverse. I'm still mystified as to what it really means. I know what osmosis is, you know, when something kind of seeps, you know, under kind of a molecular kind of, you know, pressure. Actually, osmosis for me is something that happens without applying any pressure. You know, it's actually the difference of pressure between the two media that's kind of natural, right? I can never figure out the reverse part, you know, by the way. Maybe you should, you know, help people out, you know, by telling them what reverse osmosis is and kind of help them understand that a little bit better.
Yeah, regular osmosis, water goes to the part that is salty. So you get more equilibrium.
Yes, exactly.
More
Exactly.
fresh water. Reverse osmosis, you force it
You
back.
force it, you see, because everybody has an understanding of osmosis. We use it metaphorically. It's, you know, there's an osmotic spreading of ideas in American society, whatever, you know what I mean? It's something, explain what that is, but then, when explaining what that is, it kind of try to violate the expectation about, you know, how water desalination should or could or will work, right? Same with the blacktops, as they call it here in the States and some parts of the country. You know, what's blacktops made of? Well, you know, you might think that the blacktops is made, it could only be made of oil residue. Well, what if we use the substitute for it that's even better and also does these other 13 things, right? So here I got it.
Do you know they're using coffee grounds though?
Really? That's a good idea.
American University, they were using coffee grounds.
That's wonderful. Man, those people drink a lot of coffee.
Mm-hmm.
Yeah. How about burned oats? You know, would that work? Don't tell them.
They're not using mustard.
Don't tell the North Koreans. Then tell the North Koreans. Or maybe tell them, you know, they'll have a revolution in no time. All right, so, yeah, so again, think about violating assumptions, but assumptions that you understand. You need to know what your people think about your stuff before you start telling them the story. Use metaphors all the time that speak about this type of violating assumptions. Again, don't emphasize too much the technical part. No, don't be atechnical. You see, there's a very fine balance between saying nothing about the technical aspects, because that really makes you look bad. You know, it's like, you know, she's making it up. At the same time, you know, don't overwhelm the public with very technical stuff. Don't tell the audience anything that you would, don't give the public any type of explanation that sounds like an explanation you give to a colleague of yours that doesn't work in the same lab with you. Don't rely on any common knowledge, any specialized common knowledge between you and the audience. There you lose them. They're gone. Right? Again, start with the end. I noticed that the ones who use jokes or stories tend to get caught in the stories a little bit too much and spend a little bit too much time with those stories. And one reason was also because you did not front load the thing, right? You did not give me, you know, the reason why you are telling me the story from the very beginning so that I could follow you to the ultimate destination, right? You know, give me some sort of, you know, kind of bait at the very beginning, right? I really like the story about Joe growing up in Jordan and, you know, thing breaking all the time and all that. But again, you know, that example kind of went, you know, the opposite way. But, you know, you could say, you know, imagine a world in which things don't break. And I can't tell you how important this is for some people, because I'm one of those people who suffer from things breaking around me all the time, right? So you can tell, you know, and actually, you know, I could have confessed, you know, I grew up in a place, you know, the nearest store was an hour away. And each time this thing, you know, broke, I had to drive for an hour to get it. How sad that is. Imagine that I had this thing that did not break, that replaced, and I need to go to the store too, right? And then, you know, then transitioning. You know, your intro cannot be like half of your time, right? You know, it can only be, I don't know, like 30 seconds.
So you have 5 minutes for this pitch, and when we send out that article about making your work interesting, we'll send out the specifications for it as well. So with a 5-minute pitch, you really should, your intro should be just 30 to 45 seconds tops, and you also want to make sure that you end on a very high note, because there's a phenomenon called the primacy and recency effect. People tend to remember the first and last things that they hear. So you want to start out really strong, you want to end really strong. So if you are presenting as a group, start out and end out with your strongest speaker. And those are just some additional tips to help you in terms of structure.
And there's no sin in having a designated speaker. Nobody will think the worst about you. But what's really important is that the team wins the competition, not that, you know, everybody gets a chance to play. You know what I mean? You know, there's no shame in designating somebody, treating that person like, like the driver of the truck that she is, cheer her up, work with her and provide her all the support she needs. Be her worst critic when you do rehearsals, right? And actually that's why it's good to have one speaker, because the other two can act as me, right? Like, whoa, hold on a second. You started with the beginning again. Start with the end. Didn't I tell you to start with the end? Right? And that kind of stuff. That's about it as far as I'm concerned.
Thank you all so much. This was a pretty rapid fire exercise, and I really commend the fact that within 20, 25 minutes you were able to come up with the work that you came up with. And I appreciate you coming, and I'm looking forward to a couple weeks. If you have questions in the meantime, please feel free to reach out.
Yeah, and we're really excited about this, and I'm telling you, this can take the place. You will never know.
Yeah, and I guess maybe what I should add is that don't be afraid of the sharks. Is that the idea is that you learn better being in a situation where you are on certain boundary condition and pressure. And also what you did today, the subject you chose and so on, that was an exercise.
Yes, yes.
You can continue the same, or you want to choose something else, you have 2 weeks to do that.
Yeah, and choose a winning argument, choose a winning example. Choose it doesn't have to be the coolest thing, the thing that will give you your PhD, okay? It doesn't have to be your thesis. Fight with your advisor if your advisor insists on talking about that. Like, no, man, it's not in the story, everybody knows about it. Let me tell you this other story, all right? Thank you so very much, I really appreciate your time.
Thank you all.
Thank you.